Okay, so for this video, we will discuss on the concentration of solutions. Okay, so take note of the title class that it's concentration of solutions. Okay, that means concentration describes solutions. Okay, so that means if you have a solution, that solution must have some concentration. So let's define concentration and solutions first. Okay, so just like length class, like length, diba? Length can be measured. Length is a quantity that can be measured in inches, it can be measured in cm, diba? It can be measured in several units, which you can just interconvert, diba? Convert one unit to another. Concentration is the same. It's a quantity that can be measured in molarity, molality, and many more, which we will discuss later. Now, let's say, for example, we have this beaker with 500 ml of water. Okay? So, I added 10 grams of salt, sodium chloride. I added 10 grams of salt to this. Now, by experience, you know that the 10 grams of salt will dissolve in 500 ml water. That's 10 grams. Mura na siya maybe a pinch of salt or 3 pinches siguro of salt. And that's tunga sa litro nga tubig, di ba? So by experience, you know that this will dissolve upon stirring, right? So you don't see the salt anymore, but you know that this liquid inside the beaker is salty already because it's now called a salt solution. So this one is called a solution. So a solution is where there is a solute and there's a solvent. Ang solute is ang substance that you dissolve. So ang salt mao to ang solute. And the substance that dissolved the solute is called the solvent. So when you now have a solute and a solvent, you can have a solution. You form the solution. Okay? Now, solution can either be dilute or concentrated. So, for example, these terms are actually relative. So, for example, this solution, this 10 grams of sodium chloride in 500 ml water. So, 10 grams of sodium chloride per 500 ml water is dilute as compared to if I added 250 grams of sodium chloride per 500 ml of water. Diba? Okay. So, you understand a solution now. So, this thing here, kining 10 grams per 10 grams sodium chloride per 500 ml o 250 grams, this is called the concentration of the solution. Okay? So, it's just the unit. Kung unsa ka espiso or kung unsa ka layaw or lasaw ang imuhang solution. Okay? That's what you call as the concentration. So, let's start with kanang the most common na concentration used in books and other reading materials. So, first off is the molarity. So, molarity is a unit of concentration. It has a symbol M, capital M, which is equal to the moles of solute per 1 liter of solution. Okay? Moles of solute per 1 liter of solution. That's the concentration of, that's the molarity, the concentration of the solution in molarity. Okay? So, for example, typical seawater contains 2.7 grams of salt per 100 ml. So, it's saying nga, if mauni ang 100 ml nga seawater, ang content ana is 2.7 grams of salt. Ang naaana, or sodium chloride. What is the molarity of sodium chloride in the ocean? Okay, so I suggest nga before you answer the class, you have to understand the problem. Because this is analytical chemistry. From the word itself, it's analytical. You really need to analyze the problem before you solve it. Okay? So, we are asked to find the molarity, the concentration of this seawater, the concentration of seawater in terms of molarity. Okay, now we know molarity is in moles solute per 1 liter of solution, and we already have this, right? We already have this. So, that means molarity is equal to, that's 2.7 grams of salt, or sodium chloride, sorry, per 100 ml of seawater or solution. Diba? Kaya mo man ang atong solution, ang seawater. Diba? Okay, so, you already have the mass of sodium chloride. How do you convert that mass into moles? You just use the molar mass. Okay, so that's the molar mass of sodium chloride is 55.85, 23.1, sorry, 58.55 rather. 58.55 grams of sodium chloride per 1 mole of sodium chloride, right? Diba? 1 mole of sodium chloride is equal to 58.55 grams of sodium chloride. And you can cancel this out. So now you have moles. And okay na imong numerator. Okay na ning. Then you have 100 ml of solution, but you need liters. So you just convert ml to liters. And it says here that 100 ml is equal to 100 times 10 to the minus 3 liters, diba? So, you just cancel that out, and you get, it's the answer, 2.7 times 100 divided by 58.55 times 1. Okay. 2.7 times 100 ml over 100 over, sorry, 0.1. 58.55. Okay, you have 0.46 moles of sodium chloride per liter of seawater, or per liter solution, or that's 0.46 molar. Okay, now let's try letter B. Magnesium chloride has a concentration of 0.054 molar in the ocean. How many grams of magnesium chloride are present in 25 ml of seawater? So, if this is 25 ml, so for example, you took 25 ml of seawater. You're told nga its concentration is 0.054 molar. So, all you need to find is the numerator, right? Pila ka moles sa solute. Because you're asked for the grams, you can just convert the moles to grams. So, you're given 0.054 moles of MgCl2 per liter of MgCl2. I mean, solution, sorry. Of seawater, right? So, the molar mass of MgCl2 is, what's the molar mass of MgCl2? weight, MgCl2 molar mass. That's 95.211. So, you have moles yung dapat diri sa ubos, diba? So, 95.211 grams MgCl2 per 1 mole, diba? So, you can cancel moles. Now, you have the grams. But here, you have liters pa man, and you're given 25 ml. So, you just multiply that with 25 ml. Then, you just convert the ml. So, multiply that with 1000 ml is equal to 1 liter. Right? Okay, so, makancel ni ang ml. Sorry class, ato tarungan kasi. I don't know how. 25 ml over 1000. That's basically it. So now you have cancel po na ang liters, diba? So 0.054 times 95.211 times 25 divided by 1000. So you have 0.13 grams of MgCl2. Kay grams naman lang nabilin, diba? Now you have the answer. Okay? Okay, so next, let's try another problem. So a concentrated solution of aqueous ammonia is 28% weight per weight and has a density of 0.899 grams per ml. What is the molar concentration of ammonia in this solution? So the problem is giving you this data, this info. You have this ammonia solution, aqueous ammonia solution. Okay, so this is the ammonia solution, and you are told that this is 28.0 weight per weight ammonia. If it says 28.0 weight per weight, that means you have 28% pa man na, diba? So if it's percent, you need to divide that by 100. So you just move 2 decimal places to the left, gikan sa decimal point. So that means you have 0.28 grams of ammonia per 1 gram of solution, the ammonia solution. Okay? Now, you're also told that this solution has a density of 0.899 grams per ml. Now, what does density mean? It's actually 0.899 grams of the solution, ammonia solution, per ml of ammonia solution. Okay, so basically class, ang density ra jud is murag ang weight relative to the volume. Okay? So, ginsa na pagkuha, it's just gitimbang ni kini nga solution, gitimbang ni, and so it gitimbang na siya ang kanang solution, and then gitake pod ang volume. Okay? And then you just solve it relative to kanang para ma-cancel na ang ml. I mean 1 ml na ni siya. Okay, relative to 1 ml. So, you are asked for the molar concentration, and as your, diba, molarity is equal to the moles of solute per liter of solution. Now, you already have the moles of solute here because you know that this is 28% weight per weight, diba? which is equal to 0.28 grams ammonia per 1 gram of the ammonia solution. So, you now have 0.28 grams ammonia per 1 gram of ammonia solution. You have to understand this kanang usa ka term ba, kanang numerator over denominator. You have to understand what it means. It means nga for every 1 gram of the solution, naato siya 0.28 grams of ammonia. So if na ako'y 2 grams of solution, that means I have 0.56 grams of ammonia. Right? Okay. So what you're trying to find is how much, I mean, what is the concentration of this ammonia solution? Okay? Okay, so you have this you have this information. So what you can do is, you just because we are interested in mole solutes, so we just convert grams ammonia into moles ammonia by using the molar mass. So that's 17 grams of ammonia, which is the molar mass per 1 mole of ammonia. This is the molar mass of ammonia. Okay? So, cancel mo ang grams. Now, you're left with mole ammonia. So, okay na ka sa numerator. And then, 1 gram of ammonia solution, you can convert grams into volume by using the density of that solution. So, it says that the density is 0.899 grams of solution per ml of solution. Diba? So, cancel na nimong grams. Now, you're interested kay dapat liters ang denominator, diba? Because that is the molarity nga unit. So, you just need to convert ml to liters, which wherein 1000 ml is equal to 1 liter. And you solve it, you get 0.28 times 0.899 times 1000. 0.28, 0.899 times 1000, 17. That's 14.8 molar. So it's really concentrated of aqueous ammonia. Okay? The next unit is the normality. This is rarely used, but however we shall discuss it here because some books use normality. Okay, so normality makes use of equivalence. So this makes use of the stoichiometry in a chemical reaction. So to solve for the normality of a solution, you need to know how that solution will react in a chemical reaction. Okay? So, for example, in an acid-base reaction, for example, here, we need to calculate the equivalent weight and the normality for a solution of 6 molar phosphoric acid given the following reaction. So, for A, the phosphoric acid reacts with 3 hydroxide to form phosphate ion. Okay? So that means it has 3 number of equivalents because it reacted to 3 OH. Okay? So to compute for the equivalent weight, so for letter A, to compute for the equivalent weight, you can just use the formula weight or the molar mass, okay? Formula weight of phosphoric acid over the number of equivalents. So in here, the formula weight is, diba, phosphoric acid, the formula weight of phosphoric acid is, it's 98. Yeah, it's 98. So that's 98 And the number of equivalents is the number of H's that reacted to the number of OH, because this is an acid-base reaction, diba? So, all 3 H reacted to OH, that means 3 yung number of equivalents, diba? So, that gives you 98 divided by 3 is equal to 32.7. 32.7, diba? So, that's the equivalent weight. And to compute for the normality, you just use the molarity. So, this is the relationship of normality and molarity. So, you just use the formula the normality is equal to the number of equivalents multiplied by the molarity. So, that gives you 3 number of equivalents times 6.0 molar. That gives you 18 normal. Okay? So, that means for B, we have 98. And how many number of equivalents? So, it only reacted to 2 ammonia. Diba? Nawa. It gives you HPO4 to minus. Okay? So, that gives you 2 number of equivalents. And so, it's 49. And so, the normality is then equal to 2 times 6.0. 6.0 molar, which is equal to 12 normal. Okay. Now, for letter C, we have equivalent weight is equal to 98 over how many number of equivalents? So, it reacted only to one base. Diba? Nabilin pa ang duha ka H. So, that's 1. That's 1, which is equal to 98. And so, the normality is equal to 1 times 6.0 molar. So, in here, the normality is equal to molarity. 6 normal. So, usually class, in acid-base reaction nga, isa ra kabuok ionizable H, usa ra kabuok acidic H. Like HCl, diba, HBr, those acids. Ang normality niya is equal jud siya sa molarity. Kay 1 raman yung equivalence. So, it only differs if daghan ang number of equivalents. Okay? Okay, so another unit that we need to know is molality. Okay, so molality is equal. It's like molarity. Okay, so the unit for molality is small letter m. Do not confuse this with molarity. The symbol of molarity is capital M. Okay, so this one is molality, which is equal to the moles of solute per kilogram of the solvent. Okay, so take note ha. The difference with molarity is ang molality, it uses kilogram of solvent. Now the advantage of this class is that it's now temperature independent. Okay, because ang molarity man good, when you change the temperature, the volume of the solution might change, diba? So ang kining molality nga unit is kanang usually used in thermodynamic nga mga calculations wherein they want the concentration to be independent with temperature. Okay, but some books still use molality and even some labs. Okay, and so another unit that you need to know is percent weight, even though we have encountered this from the previous example. So if you're told that a solution is 37.0 weight percent, that means that that solution has 37 grams of HCl per 100 grams of that solution. Okay? Or it could also mean it's just this will be just the same. It could be 0.37 grams of HCl per 1 gram of that solution. Or it could also mean 0.37 kilograms of HCl per kilogram of solution. Okay, so they're just the same as long as it becomes 37 when you compute it. Okay, it becomes 37%. And another important thing to note here nga, ang unit of the numerator and denominator must be the same. That's why it's weight per weight. And it's weight of the solute per weight of the solution. Okay? And it's the same with volume. Volume per volume or volume percent. Okay, so instead nga grams lang, of course, you use the unit of volume like ml, liters. Okay? Okay, so I hope I hope you get this idea, class, ha, because this is very important. Okay, so now let's try to solve the problem. So we are asked to find the molarity and the molality of a 37% weight HCl. And the density of that solution is 1.19 grams per ml. Okay, so let's write the formulas first. So molarity, or capital M, it's mole solute per liter of solution. Okay. So for molarity, class, molarity, it's simple, di ba? We can just use the density. Okay, so the density, let's write the given first. Okay, so the density, we are told that the density is 1.19 grams of solution per ml of solution. Diba? And also, we're told that it's 37% weight. Diba? So, in this case, class, because we are so told that it's 37% weight. Diba? So, let's assume that we have 100 grams. Okay? Let's assume that we have 100 grams of solution. Okay, so, mauna itong assume, ha? That means we have 37 grams of HCl is present in 100 grams of solution. Diba? That means ang weight sa solvent would be, that means the weight of the solvent would be the weight of solution minus the weight of the solute. And that's weight of solution is 100 grams minus the weight of solute, which is 37 grams. Diba? Which means that's, how much is that? 63. 63 grams H2O. Okay, so for every 100 grams of solution, 63 grams na water, ang 37 grams is HCl. Okay? So now you have the kilogram of solvent, you have the liter of solution because you have this, and you know the moles of solute because you have this grams of HCl, diba? Okay, so let's find the mole of solute first. So for every 100 gram solution, so the moles of solute, let's just compute the molarity. The molarity is equal to, we have 37 grams of HCl for every 100 grams of solution, diba? Oh, sorry, it means, so you can convert the mass to moles by using the molar mass. That's, the molar mass of HCl is 36.65 36.55 grams of HCl per 1 mole of HCl. Right? Now you can cancel grams, so you're left with moles, so you're done. And then you now have you just need to change the grams of solution into the liters of solution. So grams to to volume is, you can just use the density. So you have 1.19 grams of solution per ml of solution. So you can cancel gram solution. You're left with ml, but you need to change that into liters, which means you just need to convert that. 1000 ml is equal to 1 liter. And now you're left with moles per liter. So the concentration is, in molarity, is 37 times 1.19 times 1000 divided by 100 times 36.55. That's 12.05. So the molarity is 12.05 molar. Okay? Now, the molality is just the mole solute, so you use the same solution, 37 grams of HCl, that's mole solute, diba? Per 100 grams of solution. Right? You just, what you need to do is, you need to compute the moles of HCl for every 100 grams of solution because you assume 100 grams of solution, diba? So let's just compute because we already know the volume of the solvent. So let's just compute for, where is it? No. Okay. Okay, so let's just compute for the moles of solid. Okay. So the moles HCl in for ev in 100 ml solution. Okay, this is what we're trying to compute. So the moles is, since we have 37 grams HCl in every 100 ml, so that would be 36.55 grams HCl per every mole. So that gives us 37.37 divided by 36.55. So there's 1.0123 mole HCl in 100 ml of solution. Diba? So, to compute for the molality, you can just use 1.0123 mole divided by 63 grams, or that's equal to 0.063 kilograms of H2O or the solvent, diba? So that gives us 16.07. 16.07 molal. Okay? Did you get that? Okay.